All right, guys, welcome back. We've been looking at the vertex form of the quadratic equation, and the end of yesterday's lesson, we kind of tied everything together, but it was fairly quick and probably glossed over by a lot of you guys. Today, we want to focus on the vertex form and why it's helpful. But before we do that, before we can say why it's helpful, we got to make sure we remember what it's all about. So the A of the quadratic equation will take care of the stretch and the compression, so how fat or skinny something is. And this depends on the A value. So if it's a stretch, then the number is greater than 1 or less than -1, which is a fancy way of saying that if we ignore the sign, the number is bigger than 1. The compression, so how flat it's going to be, depends on the value being between -1 and 1. Again, in student parlance, you guys like to describe it as being a decimal. I will not accept this on a test or an assignment as being an answer, but there's nothing wrong with thinking of it that way so long as you get it right in your head. There, of course, is a reflection in the x-axis if A is negative. Okay, there is no real short form for that one. It's unfortunately the way it is. If we look at the H, then things get translated left or right. And remember that the signs are opposite. So for me, I tend to just think of it as being like that. And K moves things up or down. Now, the reason this is called the vertex form of the quadratic equation is that to find our vertex, we just change the signs of the H to get our X and the sign and plug in K. So our vertex becomes negative HK. The axis of symmetry is a formula, and the step pattern now, don't worry if you don't know what the step pattern is right now. We're actually going to explore that on the next page. This sheet was meant to be kind of a quick crib notes for you if you ran into troubles and had to have something to look back at real quickly rather than trying to flip through every lesson. This is the important page that essentially summarizes the entire unit for you. So parent function is y equals x squared. So the king parabola, in other words, 1, 0. And if we look at our first differences, we could actually graph based on the first differences. So I know that my vertex is at 0. If I go over 1, up 1, I can find my next point. Over 1, up 3, there's my next point. Over 1, up, oh, what is that? 5. So that takes us all the way up to the 9. We can find my next point. So just like when you're graphing linear equations, there's a shortcut method to graphing this sucker. And let's face it, we like shortcuts. It does make things easier because who really wants to make a table all the time? So the step pattern, as you've probably noticed, are the odd numbers. Now we don't mean that the number that's going to be in the cafeteria eating lunch by itself because nobody wants to sit near it because it's too odd. We mean 1, 3, 5, 7. All right. This works well if A equals 1. But what happens if A doesn't equal 1? Well, it turns out that it's not so difficult. Whatever the value of A is, we multiply the step pattern by that number. Okay, so it might not seem the clearest right now, but fortunately we have a few examples lined up. So here we have the graph 2x plus 1. All right, and the question is asking us for the transformations. So it's being stretched by a factor of 2 translated 1 unit. Because it's outside the brackets, up. So what it means is that my vertex is being moved from here to here, and I have a stretch factor. Okay, so we'll look at some of these details first. It's still up. My vertex has moved up 1, and my step pattern is being multiplied by 2. I'm sorry. So instead of it being 1, 3, 5, 7, it's now 2, 6, 10, 14. So over 1, up 2, over 1, up 6. If my graph went that high, I could graph this a little more accurately. It does not, so that's as far as I can go accurately. Okay, let's try the next one. Here we have one that's opened a different way. So our transformations, remember your terminology. Okay, so the negative sign tells us it's reflected. The plus 2 tells us it's moved up 2 units. So since it's a negative, it opens down. We haven't done any left to right switches. So once again, that was a 2. And our step pattern in this case, since A is a negative number, the step pattern still holds down. Right? And it's the same thing. Over 1, down 1. Over 1, down 3 in this case. Okay, so it still holds. At this point, you should be getting comfortable. So if you want to give it a shot, go ahead. Now this time, instead of it, and it always messes with my head, so since it's in the brackets, we got to change the sign. Okay? So it's a negative A, so it's opening down. My vertex this time, it's the X value that's changed, not the Y. And the step pattern, since it's a negative 2, which one am I looking at? Oh, there we go. Negative 3, there we are. All right, and away we go for graphing. Now, pay attention to the scale. Notice it's by 2, so that means I'm going over, get over, there we go. What did I say? 9, 2, 4, 6, 8, 9, 15. Oh, that might fit. 2, 4, 6, 8, 10, 12, 14, 15, ping, and ping. Notice I'm only counting on one side. As you will no doubt remember, parabolas have that line of symmetry, so it means that whatever you find on one side has got to exist on the other side. Just make sure that your points are equally far away from the line of symmetry. All right, so slightly harder, but give it a shot. And I was just thinking, I really don't know why we have to specify that it's compressed and stretched when the A value, right, whether it's a 4 or whether it's a 0.5, gives it away. Unfortunately, I didn't invent this. That's just the way it is. -3, so that means it's actually to the right. Now I'm displaying bad form here. It really should be translated 2 units down. Yeah. Direction of opening. Up. Vertex. So change the sign of what's in the brackets and keep the sign of the one outside the brackets. Our step pattern, assuming you're good enough to do this in your head. Although halves is actually pretty nice because it's just a regular step pattern over 2. And let's go and graph. So my vertex is at 3, -2, over 1, down a half, over 1, down 1.5, and because I'm, well, over 1, down 3.5, so what is that? 3 halves, I'm sorry. Oh, that is 3 halves. 5 halves, so down 1, 2.5. And I could keep going. I'm not gonna, but I could. And your parabola is going to look something like that. So find your vertex first, and then use your A value to graph it. Jinkies. As always, I'll fix this up when I type up the PDF. For those who don't know, this is MC Hammer, who made the song It's Hammer Time. So, you know, New York time, London time, Tokyo time. Oh, they took off my... I used to have where it said homework time on for that last one. Ah, well, anyways, have yourself a good one.